All right then. Well, let me in that case start the screen sharing, and let me share my screen and slides. So right now I'm presenting my presentation, just verifying that it's visible. Okay, cool. Glad that you can hear me. All right, so let's get started. Well, welcome everyone to Trading Safely in Java. My name is PRESLAV, and well, today we're going to cover quite an interesting topic. But before we start, let me just quickly introduce myself. This is me in a more informal light with my COVID sweatpants, and in general, I'm a guy who likes programming, teaching, and speaking. Since there wasn't a speaking emoji, I gotta use the other techniques to achieve what I want here. I'm a software engineer at Uber, and I'm currently doing some microservice development in Java and Go. One of our main services in Java, we do a lot of batch processing, which is inherently a multi-threaded environment. And today I'm going to show you some of the stuff we are encountering ourselves. Apart from that, have been teaching and leading lectures and seminars for maybe around 5 years now, and continuing the effort today. And if you want to check out some other things I've talked about or worked on, you can check out my GitHub or my personal site. But since we're kind of short on time, I want to get started with the main event today, which is trading safely in Java. And one of the first things to consider is why not making a token concurrency. All right, so before I continue here, let me just quickly check the chat that no one is complaining about not seeing the screen. Okay, so people are just saying hi. This is a good indicator that everything's going okay. So why not a token concurrency? Well, in my experience, I've seen that most courses and books on this subject are kind of incomplete when talking about concurrency, because really they don't cover thread safety to enough extent. At most, some people just tell you that there's this keyword in Java called Synchronize you can use to achieve thread safety, but unfortunately that's not enough to understand the intricacies of using it. And it seems to me that we are teaching concurrency nowadays as if we're teaching people to ride a very high-speed car by showing them how to gas their way to 200 miles per hour while not learning how to drive safely first. And this talk today is aimed at bridging that gap. And there are two goals which I want to achieve today. First is to cover the fundamentals, which some of them you might already know. Others are probably a surprise for many of you, and we'll see today because we have a couple of polls I've prepared for you already. But more importantly, I'm going to show you some resources in the end, which you can go through in order to not get into the trap of going through a bundle of concurrency courses and guides and seminars and workshops and not understanding it fully, because that's probably something some of you might have experienced already, because you always feel that there's something you don't know yet. And in this talk, I'm going to show you how to bridge the gaps in your knowledge you already have. Okay, and in terms of the agenda, the first part of the talk is going to be focused on the purpose of caring about this subject at all, because from what I've seen, many people underestimate the importance of thread safety, because people feel like they are safe from it, although oftentimes that's not the case, and we'll see why that is. Then we're going to cover some of the basic issues you could have when talking about thread safety, some of the fundamentals which you should consider, and how to address them in Java. And finally, we're going to see how to expand the knowledge you're going to gain from this talk and grow your skills and knowledge from there. But there's also this big list of things we aren't going to talk about. However, this list can serve you as a guidance to what you probably don't yet know about concurrency in Java and what you still have to learn, and tick off each of these items after the talk is done and you go study it on your own. And in order to not just present you with a bucket list of stuff, which some of them are very daunting, I have prioritized what's the most important things to know. The first four, unfortunately, I wasn't able to bundle in this talk. I did attempt to put the first two, which are quite important, about initialization, safety, immutable objects, and about thread confinement in this talk, but I didn't find enough time to put that all, while also covering in enough depth the rest of the things which are already in the agenda. However, if you stay until the end, I'm going to show you how to actually gain knowledge and all these additional stuff, which some of them are important to know, others are, well, good to know. Okay, cool. And the first part is about understanding what thread safety means at all. Quickly gazing at the chat if there's anything there, or the Q&A, nothing there. Okay, so let us continue then. So what's thread safety at all? Well, one simple way to define it is that imagine first you have a class which does certain things, and we're not talking about multi-threading at all right now. And this class is supposed to behave correctly. So what does behaving correctly mean? Well, let's say it means the class should behave as per requirement. So if the requirement is for your class to provide something like a cache for given values, the cache should work as expected. You should probably have some tests to make sure the behavior is sustained while you develop your project. Thread safety, on the other hand, is expanding this notion of behaving correctly into classes which not only behave correctly, but also continue to do so while they are bombarded by a gazillion of threads. And as you see throughout this talk, we're going to see examples of classes which actually look quite okay at first glance. And many of you have probably written such classes before or continue to write still, but yet they have certain issues once you start using them with a bunch of threads. Okay, so another thing to consider, should you care about thread safety at all? And one thing which I often hear, I recently heard as well from a web development friend of mine while preparing for this talk, that you don't need thread safety to know about thread safety because you're not really spawning any threads anywhere. You don't have thread.run, you don't have executors, you don't have whatever. You're just writing simple web apps, for example, and you really don't need to consider thread safety because you're assuming that you aren't running in a multi-threaded environment. So that's what many people first think when considering this topic. However, I have some bad news for you, because if you are writing web apps, if you are using Spring, if you are using some other kind of framework which serves web requests, you are already writing multi-threaded applications. Why is that? Well, because although you aren't spawning threads directly, you don't have anywhere creation of new threads throughout your own code base, you are using a framework which works in a multi-threaded environment. For example, Spring. Every time you get a new request over the web, let's say a GET request or a POST request, the framework doesn't process those requests sequentially. It actually spawns several threads, and processes those requests in parallel so that your application can scale better for the modern web. Meaning that all your classes which handle your web code, all your REST controllers, all your classes which the REST controllers depend on, should be thread safe if you want to avoid some very subtle bugs which might occur in such an environment. And here's an example of a very simple web application which seems quite okay at first glance. It's simply a chat application where you have a mapping between users and messages. You have a REST API for messages where you can send a GET message and get the messages for given users, or you can send messages and they are persisted in that hash map. And this is a very simple application, and yet it's not thread safe. And if you run this application with a sufficient amount of users, you will most likely run into very subtle problems which will be hard to understand, reason about, and discover. And I won't cover what the problems of this code right here are right now. However, after this talk finishes, hopefully you will have the knowledge to understand what's wrong with it already, and resolve the problem on your own, know how to handle it. By the way, with that friend I told you about, when he told me that he doesn't need thread safety because he just has a web app and they don't need to care about thread safety, I told him, okay, can you tell me a single instance in your application where you're using a hash map? And he showed me a single instance where he did use a hash map, and 5 minutes later, we already saw a thread safety violation. So if you go in your code base after this talk, perhaps you will discover certain bugs like that already. But before we can reach that point, we will have to actually first learn what kind of problems one might encounter around thread safety. Okay, quickly gazing in the chat again, nothing yet. By the way, if you have any questions throughout the talk, I'll leave a question in the Q&A or in the chat, and I'll address it either throughout the talk or at the end, depending on the questions. I'll decide subjectively how to handle it on demand. All right, so what we covered so far is the importance of thread safety, and hopefully if this application we just saw resembles something you have written and you haven't found any issue in it yet, then probably you missed some understanding about thread safety, which now we're going to cover. Not all the problems, because as I said, some of the stuff about thread safety are out of scope of the talk, but the most important bits are going to be covered in this talk. And we are going to start with first understanding when there is potentially a thread safety issue. So consider this class. It has two methods. One is called weekends safe, one is called weekends unsafe. In one occasion, you have a concurrent hash map, which seems like something related to thread safe access. In the other case, you have a normal hash map, which actually very much resembles this example here. It's a normal hash map as well. You put some values and you return it. And my question to you now is the class thread safe? So you can join on slido.com and this event here so that we see what your understanding is so far of this specific class. The event code is 93849. Let me double check if that's still correct. Oh, wow, it changed. Okay, so it's 94849. Okay, so it's this one. Apologies if you already typed the other one. But yeah, please join this event here. At Slido, you can use your phone or your laptop, whatever is more appropriate. And we are going to cover the quiz. Come on, go ahead. Start the quiz. Is it thread safe? No, not this one. Apologies, this one. Which method is thread safe? So is it weekends unsafe, weekend safe, neither, or both? All right, so waiting for you to join right now. Probably going to be a little bit of delay because it seems that there is some delay between the stream and the actual, well, event of me talking. So I'm going to wait a bit. All right, so one person, thanks for being the first follower, joined and said that neither thread safe we can save is thread safe. All right, so 6 people have voted so far. Let me check how many participants there are so that I can evaluate when to stop the poll. Well, I actually don't see that because I only see 2 people. So I'm just going to wait for a couple of more seconds, and I'm going to give the answers for you. Give the answer for you. All right, cool. 15 people, neither. Okay, we can save. All right. Okay, so I think I'll just give out the answer now. So first, I'm happy that this happened because it means that this talk is actually going to be quite useful, because it seems that many people here didn't get it right. Because the answer is that among these 2 methods, both are thread safe. So only 13 people among 23 voted that both of them are thread safe. Most thought that neither are thread safe or one is thread safe, but actually both of them don't have any issue with them. Although one uses a concurrent hash map, which is a thread safe collection, and one uses a normal hash map. Both of them don't have any issue whatsoever. And the reason is because when talking about thread safety issues, we have an issue regarding thread safety whenever we are accessing shared mutable state. So what do I mean by that? Imagine this schedule, graphic here. You have 2 threads which can access different parts of memory. One thing you could access is the stack which each thread has, and the heap memory which is used explicitly by that thread. In this case, thread 1 has a non-shared state which is residing in the heap. It can theoretically be shared, but it's not, because only thread number 1 can access it. Thread number 2 has something similar. And the only case in which you might have a potential thread safety violation is when 2 threads are accessing shared state. And in this case here, there is no shared state because both of these functions, both of these methods are stateless. They don't depend on any state of this class. And by state, I mean some kind of property. They just depend on data which is confined to the method itself. Since this since this hash map is being created every time the method is invoked, it will always be confined to the thread which is invoking it right now. So there isn't any thread safe issues. Now, there might be thread safe issues if after receiving the map, you don't provide sufficient synchronization and things like that after you get the actual map, but that's out of scope for the question. We only care about the class itself. After the thing is received, the person has to deal with it himself. But whenever you don't have a state like this one, whenever you don't have a property inside the class, which might be shared while one thread is accessing get messages, while the other is accessing send message, when you don't have a case like this, where 2 threads are accessing the same data, you don't have a thread safety issue. So that's lesson number 1. Whenever you have a stateless method, you don't have to worry about thread safety. All right, so let me end that poll right now. And the next section we're going to cover is atomic access to shared state. But before that, let me see what people are saying in the chat. Can we see the code again, please? Well, I think that's already quite outdated 4 minutes ago. Yeah, probably I should have shared it previously, but already shared it a couple of times. Apologies if that was confusing during the poll. Okay, but yeah, in this case, you don't have properties in the class. The variables are inside the method, so you don't really have to deal with, you don't really have thread safety issues here. As Mikhail just said, local variables are thread safe, and that is totally true. All right, well, now let's see what happens when we introduce state variables or properties inside the class. Imagine that we have this class here called hit counter, and we have two methods. One is hit, the other is get. The hit method, what it does is it increments the counter. And again, the question here is this class thread safe? So this time, think about it a bit. I'm going to just share the code a bit before I go to the quiz. And right now, after perhaps the code is memorized, I'm going to start the next quiz, which is, is it thread safe? Okay. All right, so feel free to join again in Slido. You have two options here. So, well, you have a higher chance of getting it right this time. This is the class again. The meeting code is 94849. So just don't close the window when you first enter the app, and you won't have to type it in every time again. Okay, so one person is in but hasn't answered anything yet. I'll wait a bit for the answers. In the meantime, I'll just show the code so that it's evident. Let me see how time control is. Okay, at my end, it's 2:26, so we have 30 more minutes. Okay. Why isn't anyone choosing anything? Do I have to click something? Oh, okay, cool. Sorry, was confused by Slido's UI. So most people here are saying that the class is not thread safe. Some people are saying that it is thread safe. Lovely. The correct answer here is that the class is not thread safe. Continuing what we were covering previously, whenever you have shared mutable state, we might have a thread safety issue. In this case, we have shared mutable state because this counter here can be accessed by threads which are accessing hit and get. And by the way, one remark to make here, I am talking about accessing the same instance of the class. So imagine that you have an instance of this class hit counter and two threads are accessing the same instance. This is what typically happens, let's say, in web applications, by the way, because when you inject your dependency, it's typically a singleton, meaning that there's only one instance shared across multiple requests. If you have a separate instance per thread, no matter how you bombard this code, there won't be any thread safety issues. But if you have a single instance which is shared from multiple threads, then you might have a thread safety issue. And in this case, what's the problem? Well, first, there are several, but I'm going to focus only on problems which are related to writes, so to changing the state. In order to demonstrate this, I'm going to copy this example here, and I'm going to go to my Scratchpad where I'm just going to demonstrate how this code really executes. So imagine that we have two threads. You have T1 and T2. One hypothetical scenario is that the two threads are going to invoke this method at the same time. Let's say thread number 1 goes here and accesses the counter. Now, counter plus plus looks like a single operation, but it's actually multiple operation just composed in this nice, lovely syntax here. Because whenever you increment a value, you first get the value and then increase it. So the first thing which happens is thread number 1 gets the value, which is the current value of the counter. Let's say the counter is currently equal to 5. So thread 1 will observe the value 5. Then thread 2 comes and executes the same operation, which is getting the current value. And it will, again, fetch the value 5. Afterwards, the first thread is actually going to execute the incrementation. And after that happens, the value recorded in this thread is going to increase to 6. Thread 2 similarly is going to do the same thing, so the value is going to be changed to 6 as well. Both of the threads are going to persist their state as they've processed it, and in the end, the final result will be 6. So it's just so happened that 2 threads incremented the counter twice, and yet it was only incremented once. And just so that if someone is wondering about, well, someone might acknowledge that there are other issues with this code. For now, just want to make a remark that I'm talking about concurrent write issues. We're going to talk about other stuff later. All right, so for now, having the knowledge we have so far, that's the most we can discover from this code. And let me show you what happens when you actually run the code, if you run it yourself. This is an example of me testing the actual thread safety violation. And when I run the non-thread safe example from multiple threads, I incremented the counter 10,000 times, and the final result was obviously wrong. While when I was using the thread safe example, which I'll show you in a second, I got the correct result. That's the difference between thread safe and between a thread safe and a non-thread safe class. And by the way, that's one of the differences. Typically, you might get correct results and incorrect results from time to time, but there might be others. For now, we're only focusing on making sure the behavior of the class is correct. And by the way, how to address this issue? One way is to use this special keyword in Java called Synchronize. What this keyword does is it introduces a lock for this method, and every time a thread invokes this method, if another thread comes now and tries to invoke the method, it will first have to wait for the thread which came first to finish. So if I have to run through this example again, the way it will work out this time is, let's say thread 1 enters this method, and here you have a synchronized. Thread 2 also attempts to enter the method, but now thread 2 has to wait. Whenever you have a synchronized block, if someone else is already inside that block, the other thread should wait for the first thread to finish its job. And now thread 1 will observe the value of 5, as we previously saw. It will increment it to 6 and persist the result. Afterwards, it will finish its processing of this method. So it will be out of this method. And then thread 2 will be able to enter the method and get the value of 6 now and increment it to 7, which this time will correctly process the counter and you get the correct result. Okay, so that's the basic form of achieving thread safety. Whenever you use synchronized blocks, you can achieve thread safety. And there are some nuances about how to do them. There are some more advanced locks you can use, but for starters, this is the first thing to learn about and consider. All right. Let's see if there are any questions. Nothing so far. All right, great. Cool. So let's continue with the next stuff. As I already said, Synchronized is Java's way to add critical sections or introduce locks. If you're coming from a C or C++ background, this will resemble mutexes. If you're coming from other environments, well, it really depends what you're where you're coming from, but most languages have their own alternative to achieve this. In Java, it's called Synchronized. And now I'm going to give you an action point here. Now, what this is first, to cover it after this lecture, in order to gain the most from it, I urge you to go and not only trust me that what I'm showing you is thread safe or not, but actually go home, get the examples, and try proving that the example is thread safe or not. For example, with the counter, run multiple threads, use the 2 versions of the class, and verify that when you use the non-thread version, you get a wrong result. When you use the thread-safe version, you will get the correct result. You can do a similar experiment with all the examples in this talk. And why am I making you do this? Well, first, to make sure you understand the issue yourself, and second, by practicing it, you will actually be able to remember it more easily. Okay, and it will also prepare you for the bigger action plan I'm going to give you at the end of the talk. The next thing we're going to cover is delegating thread safety. So imagine that we have this class called people1, because I have a second version of this class, and it has a hash map. Now, Hashmap is a collection which is well known. It allows you to store keys and values. But what is not so well known for it is that it's not thread safe. Meaning that if you don't have a thread safe collection and you try to use it in a multi-threaded environment, you will get incorrect results. Or more correctly said, you might get incorrect result, which is even worse. Because if you run this code, well, without the synchronized keywords here, while you're developing some the reason this happens is because you're using a collection which is not thread safe. And when you don't have a thread-safe collection, you have to use synchronization. So the way we've handled the issue here is that every time we have a getter and a setter, we put the synchronized keyword as we previously did. So this is something which is not new. We already saw how to use that in the counter. But one thing I'm going to introduce you right now is that rather than synchronizing stuff explicitly yourself every single time you have a thread safety issue, you can rely on classes which are already thread safe to provide the guarantee for you. One such class is Concurrent Hashmap. This class works the same way like the other hashmap does. It has the same behavior in normal circumstances. The difference is that this collection will also work correctly even when you use it with multiple threads. The other alternative doesn't. And when you have a class like this, you can delegate the thread safety issue to the class. And the thread safe class knows how to handle it internally. It might synchronize, it might use something else, you don't really care. But what you care about is that it does its job, it is thread safe, and all you have to do is use it as if it's just a normal hash map inside your class. Notice how in this class you don't have synchronized keywords, and yet this class is perfectly thread safe because you are using a class which is already thread safe for you. So that is the best way, in my opinion, when possible, to handle thread safety issues, by using classes which are already thread safe and relying on them. Why? Because it makes the code much more reasonable to read and understand. If you see this code, you have to reason about, did I put the synchronized keyword on the correct places? Did I miss putting it somewhere? What will happen if this and this goes wrong? When you delegate your thread safety, the only thing which, well, shows that this is code related to thread safety is the fact that this is a concurrent hash map, not a normal one. Other than that, the rest of the code is the rest of the code to some for the job. So to summarize what delegated thread safety means, it means relying on the thread safetiness of the objects you already use. That way, you don't have to deal with it yourself. Okay, so again, similarly to the previous action point, I urge you after the talk to get these two classes and verify that this fishy-looking class actually behaves correctly. Try breaking it and try getting incorrect results. Okay, cool. And the next topic is atomic compound actions. So someone asked, re-entrant log over synchronized. Okay, this is something I'm going to, all right, so I'm going to make a quick detour just to mention re-entrant logs. Now, a re-entrant log is a log similar to synchronized. It achieves the same things, but it also provides some additional features, such as providing timeouts, handling thread interruption, etc. So it has some additional features, and you could use that. And some people prefer using re-entrant logs exclusively. In my opinion, it's still fine to use synchronized whenever you don't have a big enough. It is harder to understand because it has a, it's harder to use, essentially. I won't say anything more than that because I want to focus on the talk here. But have in mind that you have other ways to achieve locking in Java, like re-entrant logs. And they provide you some advanced features which are applicable in certain scenarios. But I can't agree that they're applicable in every scenario, because for most cases, just using the good old synchronized keyword works wonders. It's sufficient. Okay, cool. Now, the next part is compound actions. So what I told you just now is that you have concurrent collections which handle the thread safety for you. And here we have this example, which doesn't have any synchronization, similar to the previous one. And what it does is it has a hash map where you can bid for certain products. And the business logic here is as follows. If a certain product is already bid for, you should return false in this function, in this method, and don't accept the new price. But if that product has not been bid for yet, you should put the new price and return true to the client that he has performed the bid successfully. There's also a getter here, which gets the price of a certain product. Okay, so what I told you just now is that when you delegate thread safety, you rely on the thread safety guarantees of the classes you use. Therefore, you need not synchronize methods yourself. And this is true for the most part. However, this class, okay, I'm going to skip this poll right now. I'm just going to spoil the issue here immediately in the interest of time. This class here is not thread safe, although it uses a concurrent hash map. Why is that? Because you have multiple actions which participate in the same logic, which is related in the same invariant, and is another way to put it. In this case, you have action number 1, which is checking that the product exists, and action number 2, which is setting the price for that product. The problem with this code is that it's true that the concurrent hash map does provide thread safety. However, it synchronizes the individual actions you invoke, meaning that whenever you invoke this line, you acquire, you can imagine that you acquire a lock, and once you're done, you release it. And when you get to this line, you acquire a lock, and once you're done, release it. The correct way to handle this is to acquire a lock throughout both of the method's execution. And this is an example of a compound action. And when you have compound actions, that's often the source of race conditions as you have right now. What kind of issue could you encounter here? Well, let me just paste this code right now. In this case, what can happen here is that thread number 1 can read the product and check that it exists. It doesn't exist, so thread number 1 reaches this point. But just before it acquires the lock for the put method, thread number 2 comes and acquires the lock for contains key. Now, since thread number 1 hasn't finished its processing yet, thread number 2 will observe that the product doesn't exist yet. So it will successfully evaluate this statement to true and reach this statement here, which is actually setting the price. At this point, thread number 1 will set the price to, let's say, 10 and return true to the client. The client goes back and is happy that he was able to successfully put the bid for the product, but suddenly thread number 2 also puts its price to the product, and now there's a second person who was able to successfully bid for that product. And client number 1, whenever he goes back the next day to see his item, he would realize that it's nowhere to be seen because someone else has put another bid, and due to a thread safety issue, they were able to snitch the product from you. And that's the source of some of the most subtle bugs in applications. And it's an example how using delegated thread safety is great, but sometimes you have to be slightly more considerate. In this specific case, what you can do is you can use the method called putIfAbsent, which essentially does the same thing. However, the difference is that Concurrent Hashmap synchronizes the internal operations of this method for you. This way, the class is again back to its good old thread safety state. And yeah, you are safe this time. So many thread safe collections have this nice feature that they provide these methods, which are frequently used compound actions like putIfAbsent. Another example is there's this class called atomic integer, which has the method get and increment. This is a compound action which is atomically synchronized. If you instead write, well, .get and then invoke the set method, you might have a race condition, but if you might have an issue, thread safety issue, but if you use the compound action, you're safe. So whenever you have a thread safe class, look for opportunities to use the compound action version of what you're trying to achieve. In this case, we're trying to achieve putIfAbsent. Sometimes this won't be available and you will have to either extend the class or use some other method to achieve what you want. And that's still possible, but it involves some slightly more complicated techniques you need to be aware of about extending existing thread safe classes, and etc. So for now, we're not going to cover that. Okay, another action point is to go and try out this example. To summarize, whenever you have compound actions, they have to be synchronized together. Otherwise, you might get race conditions or other nasty issues. And the final thing from the fundamentals we are going to cover today is about visibility. So imagine that we have this class here, which is something we already saw. And maybe some of you were itching a bit when you saw it, because you might have noticed that I synchronized both the get method and the set method. Perhaps you were itching to do this, to remove the synchronized keyword on the get method. Why? Because it's a common philosophy that you don't have thread safety issues. You can have thread safety issues on reads, just like in this room right now. While many people are viewing my screen right now, there is no thread safety issue when you have concurrent reads. There will only be an issue if multiple people start using my screen directly and writing on it, for example. That would be an example of a thread safety issue, and in that case, you have to synchronize. All right, so that's a typical way to explain this. And my question for you right now is this class thread safe? This version with a synchronized setter and an unsynchronized getter. This is the last poll for the day. Let me reset the quiz. So I will just okay. Oh, how can I reset it? All right, maybe now it is. No, sorry, it isn't. Okay, for some reason I can't reset the score, unfortunately. Is it thread safe? Yes. No. Okay, cool, launch. This is the new quiz now. Apologies. So this is the one you can vote on. All right, so it isn't thread safe. Some say it is. Let's see who will win the race right now. I'll use this opportunity to drink some water. This is the slide again. You have a synchronized setter and an unsynchronized getter. All right, 10 people voted, 12, nice. We have around 1/3 of the people saying that it's thread safe. The rest say it isn't. Lovely. So let's actually show you the answer. Well, unfortunately, I have a bad message here. And the thing is that thread safety is not only about concurrent writes. In this case, this class is not thread safe. Although that nice metaphor sounded so believable, so trustworthy, so nice, like a very wise person said it once, it's simply incorrect. At least, well, you'll see what I mean. The reason it is incorrect is because one problem with thread safety, well, one problem is when you concurrently access something, you might have some race conditions and things like that. But the other is the problem with visibility. Imagine that you have 5 lines of code and they are sequential. They're executed in your main function, main method. The Java memory model and Java, the Java virtual machine, gives you the guarantee that to the user of that application, it would appear as if those 5 commands are executed sequentially. They might not be executed sequentially. It might be the case that line number 5 is independent from the rest, and the virtual machine has the freedom to execute it independent to everything else. But even if it has certain opportunities like that, it will only, the virtual machine will only take those shortcuts if in the end result will be the same. So that's a guarantee you have. Whenever you have sequential commands, it's going to appear as if they execute sequentially, although that might not be the case. Whenever you have non-sequential commands, like commands which are executed in different threads, you don't have any guarantee whatsoever that the results from one thread will be visible in the other. And the reasons for that are something which is totally non-deterministic. You cannot say why is that, because it might be because, for example, in this case, I'll just give you a hypothesis. In this case, we have a class, you can't see me, which has 2 methods. The first method waits until a certain variable becomes true, in this case ready, and in the end checks if the number is 42. If it's not, it's the wrong number and it prints out a message. In another method, you have a thread.sleep just to simulate some initialization of this module, and then the number is being set and the ready value is being set to true. If you execute these 2 functions of the same instance of the class in 2 different threads, you might get an infinite loop, a correct answer, or a wrong number. All 3 cases are possible. The reason is that without sufficient synchronization, the Java memory model or the Java virtual machine does not give you any guarantees that this thread is going to see the results of this one. One possible reason this might be is because the virtual machine sees that you're checking for a variable, whether it changes in a thread which never changes it. So it might optimize it out. It might just remove this line and write while true instead, which introduces an infinite loop. It might happen that this value is actually observed and you get to here, but this value isn't. So you get a wrong result. And this can happen whenever you have synchronization issues. And this is an example where thread safety is not only about writing values. In this case, we don't have concurrent writes. Only one single thread writes the values, and yet we have a thread safety violation because another thread is trying to read the value which was written somewhere else. And that is why, in this case, it is not okay to make a performance optimization and remove the synchronized keyword. You should keep them both or use a thread safe collection. You cannot take a shortcut and make the getter unlocked. You have an alternative like a read-write lock for those who are interested, but you still have to use it. You can't just get away without any locking whatsoever. All right. So this is the most controversial example in this talk, which is why you have another action point to actually go here, get this code home, create an instance of this class, and run the two methods in two different threads and see what will happen. Every time I run it on my machine, I get an infinite loop. If you run it on yours, I don't guarantee you get the same result. You might get something else, but it's worth trying. So go ahead and convince yourself that this is the case. Okay, so just on time, or 5 minutes later, we are in the conclusion. So 3+1 things to remember here. When you have stateless methods, you don't care about thread safety issues. If your method doesn't have any state which is in some kind of class property, you're always thread safe. You don't need to deal with concurrent collections or whatnot. So in this case, the example we saw in the beginning, it's perfectly thread safe, although in one case you have a hash map, in the other case you have a concurrent hash map. The second thing to remember is that you should synchronize both reads and writes. It's not sufficient to synchronize only the writes, because whenever you have insufficient synchronization, you not only have issues with concurrent writes, you also have issues that the results of one thread are not guaranteed to be visible by another. That's why you need to deal with, you need to synchronize where appropriate. When to achieve thread safety, if possible, prefer delegating it to a collection or some kind of data structure which does it for you, because it makes the code much easier to understand, reason about, and use, instead of sprinkling synchronizations throughout your whole code base. In this case, we have a class which doesn't have any synchronized keywords in it, and yet it's perfectly thread safe because it uses a concurrent hash map. And the final thing, 3+1, is that whenever you have thread safe classes, you should still worry about compound actions. Thread safe classes cannot protect you whenever you are invoking two actions which are very coherent, which are dependent on each other. In this case, putting the value, the price for a certain product is dependent on the previous action, which is checking that the product exists. And if you have code like this, you are susceptible to race conditions and other thread safety issues. And you should consider alternatives, such as using, in this case, put if absent, or extending the thread safe class yourself. Okay, this is the alternative, which is actually thread safe. Now, finally, perhaps the most important thing is that all you need to know, although judging by the answers on the poll, I feel like many of the stuff we covered today was quite enlightening. Unfortunately, this is not all you need to know. I can't cover everything there is to know about concurrency in Java in 50 minutes or 55, 6, 7, 8 right now. But I'm going to give you guidance so that you don't drift from plural site course to another and waste your time. The only resource which is worth considering when talking about concurrency in Java, the only resource which is worth considering when talking about concurrency at all is the book Java Concurrency in Practice. This is the best book about concurrency, and although it has Java in its name, it's applicable to any language. If you read this book and go use Golang, you might not encounter all the stuff you have about concurrency in Java, but you will know why certain things are the way they are in Go. I've already recommended this book to a person who wants to study concurrency in Go and one who wants to study it in C++, and both of them have agreed that this is still, the best resource on concurrency, because, Java is the only, it seems to me that Java is one of the only communities which is lucky enough to have a good resource on the subject, because in Go, for example, you don't have a good resource on concurrency in Go, although there's a book with the same name which is rated with 5 out of 5 stars. It's not sufficiently well written, unfortunately. So this is what you gotta do in order to grow your skills and knowledge in the subject. And your final action point, the most important one, is to buy the book, because the author deserves it. It's a really nice book. Read every chapter at least twice, because the book is not simple. It will actually take some time to understand, but it's definitely worth the effort. It's not like a book you read and you feel like you're banging your head in the wall. Like when it feels like you're putting a lot of effort and it hurts a lot and you're not getting anything from it. It's not like that. It does take a lot of effort, but it's definitely worth it. Take book notes along the way, meaning that for every chapter, write a summary where you are summarizing the most important stuff in your own words, because that way you will actually be forced to understand it in order to explain it in a different way than the author did. And I'm not saying this because I saw a 2-minute YouTube video from a self-help guru. I'm saying that because I'm using this process myself and have used it for this book, and you can also find my notes on it in this repository I've shared. Okay, and finally, check out the action points in the slide deck and continue doing that for all the examples in the book, because most examples in the book, for most of them, you can apply the same experiment. And I urge you to do it because it's quite fun, and it will also help you understand the concepts better, way more than just going through the book and reading it. Okay, the materials for the lecture are here. bit.ly Java 2 days 2020-thread. You have a repository with all the examples and the slide deck itself. And that concludes the talk today. Hopefully this one is enlightening, and I'm open to see what questions you have. All right, thanks, cool, very well explained. All right, really glad you enjoyed it, guys. Let's see if there are any questions. There aren't. All right, cool. So I think we're already overdue. So if you want to follow up or have any follow-up questions, feel free to shoot me an email. I left it in the slide deck so that you can find me, and I'm happy to discuss anything else related to the subject. Have fun on the conference. Enjoy your time, and yeah, continue studying and growing. See you, everyone.